Dear students, we are discussing the topic heat. In earlier classes, we discussed temperature, heat, thermal equilibrium, specific heat. Here, I am again defining those terms to remind you. First, temperature. Temperature is the degree of hotness or coldness of a body. It is measured with thermometer and it is measured in units, degrees Celsius in CGS system and Kelvin in SI system. Relation between degrees Celsius and SI system also discussed in earlier class. That is 0 degrees Celsius is equal to 273 K. Here I am discussing the conversion of degrees Celsius to Kelvin. Degrees Celsius can be converted into Kelvin by adding 273 to the degrees Celsius. For example, if you want to convert 23 degrees Celsius to Kelvin, now what we will do is add 273 to degrees Celsius so that you can get Kelvin scale temperature. So this is a simple method to convert degrees Celsius to Kelvin by adding 273 to the degrees Celsius. Similarly, if the temperature is given in Kelvin, if you want to convert into degrees Celsius, there you have to subtract 273 from Kelvin scale to get the degrees Celsius. Let us see with one example. Here, suppose 300 K is given. Now to convert into degrees Celsius, here we need to subtract 273 from 300 K to get the degrees Celsius. For example, 300 minus 273, that is equal to 27 degrees Celsius. So 300 K can be converted into degrees Celsius by subtracting 273. Here we have to remember one more thing, that Kelvin scale is also termed as absolute temperature. That is 300 K or 300 absolute temperature. So Kelvin scale is also termed as absolute scale of temperature. And now here next we have to discuss the topic heat. As we discussed in the earlier class, heat is a form of energy which flows from hotter body to colder body. It is measured in calories in CGS units and joules in SI unit. Here, one more thing. This flow of heat continues between the two bodies in thermal contact up to they attain the equal temperature. For example, if two bodies are there with us, let us say body A and body B are at different temperature. Now, if you bring them to thermal contact, then the flow of heat energy may occur from A to B or from B to A until both of the bodies attain the same temperature. In this stage, we can say that these two bodies are at thermal equilibrium. Next, we discussed one more topic, that is the relation between temperature and kinetic energy by using a simple activity by sprinkling food color on hot water and on cold water. And by observing the jiggling motion of the food color, we can say that temperature is directly proportional to the kinetic energy of the particles or molecules of the substance. Next, here we discuss one more topic, that is specific heat. Specific heat is the quantity of heat required to raise the temperature of 1 gram of substance by 1 degree Celsius. Specific heat is measured with formula S is equal to Q by M into delta T, where Q is the heat energy and M is the mass, delta T is the change in temperature. From this, we can also derive the units, like units of specific heat in CGS system is calorie per kg grams degrees Celsius in CGS units. And in SI unit, the units are joule per kg Kelvin. Okay. Now, here we are going to discuss the application of specific heat. Application of specific heat. This is an important topic to be remembered because many of the terms you are getting the question from this topic. Application of specific heat. Particularly, we have to discuss one thing, that the rise or fall of temperature depends on the nature of the substance. It is, if the specific heat is more, then the rise or fall of temperature is low. And if the specific heat is low, the rise or fall of temperature is high. For example, water has the more specific heat. That's why the rate of rise in temperature for water is very low. Whereas some of the oils have specific heat less than that of the water. In that case, the rate of rise in temperature in oils is more when compared to water. This specific heat of water is applicable in our daily life. For example, the heat energy which is coming from the sun is stored by the oceans and seas, and this heat energy is transferred to the zones where there is a cold temperature. For example, the oceans are seas at equator. At equator absorbs the heat energy from the sun, and that heat energy is retained by the water, and the heat energy is transported or transferred to the pole area, so that the temperature throughout the world will remain moderate. And next, here one more question is this: when you brought out a watermelon from the refrigerator, it will remain cooler for longer. What is the reason? Here, watermelon contains a maximum quantity of water. As I said, water has the highest specific heat, so the rate of rise in temperature is low. That means the watermelon which is brought out from the fridge has a more amount of water, and the water will raise the temperature slowly. That's why it will remain cooler for longer time. And recently in exam, one more question is asked, that is, why the water is used as coolant in automobiles. The reason is the same, that is, water has high specific heat and the rate of rise in temperature is low. That means the water remains cool for longer time in the automobiles, so that it can keep the engine cooler for longer time. That's why water is used as coolant in automobiles. Now, here we are going to discuss principle of method of mixture. Principle of method of mixtures. As we discussed that the heat energy flows from one body to another body until they attain the equal temperature. Here principle of method of mixtures also give you the same content. Here, for example, if two bodies are there at different temperature, for example, let us say this is at high temperature, this is at low temperature. When these two bodies are kept in thermal contact, then the heat will be transferred from higher temperature body to the lower temperature body. In this case, the net amount of heat lost by the body at higher temperature is equal to the net amount of heat energy gained by the body which is at lower temperature. Simply, we can write the principle of method of mixtures as net heat lost is equal to net heat gained. Net heat lost by water body is equal to net heat gained by the cooler body. This is the principle of method of mixtures. So by using principle of method of mixtures, here we have to derive one formula to get the resultant temperature. That is, for example, as I told you, when these two bodies are kept in thermal contact, heat is transferred from this body to this body until they attain equal temperature. That temperature is to be found out by using this principle of method of mixtures. Now I am deriving that formula by taking one example, right? Here, let us take two different substances. This is of mass M1 and at temperature T1, and another body B of mass M2 and the temperature is T2. Now the specific heat by bringing the two bodies into thermal contact. Now the temperature attained by both the bodies will, let us say, T. Now the specific heat of this is equal to S, and the same because these two are of the same material.